Enterprise IT often operates in a state of high friction, with distinct operational units constantly pulling against each other. Development teams are evaluated on delivery speed. Platform engineering is tasked with enforcing security and scale, and finance is mandated to drive cost efficiency. Historically, scaling engineering throughput meant breaking one of those mandates. You either accepted a linear increase in infrastructure costs, or you absorbed higher security vulnerabilities to move faster. This structural conflict locks the enterprise into a permanent trade-off between devs, platform engineering, and the CFO. An internal developer platform, or IDP, sits exactly at the intersection of these competing interests. This friction is a result of fragmented architecture rather than a law of physics. Transitioning to a unified IDP architecture resolves the conflict entirely by aligning these interests from the ground up. To see how this works in practice, we need to construct this platform layer by layer, starting at the foundational runtime. The base requires a standardized Kubernetes foundation. For the platform SVP, this eliminates operational complexity and platform sprawl. For development, declarative deployments remove inconsistencies, ensuring high-fidelity testing. And for finance, automated scaling maximizes asset utilization, stopping the drain of idle server capacity. By standardizing at the container level, foundational infrastructure stops being a passive cost center and becomes an active engine for financial yield. With the foundation set, the second layer handles the actual movement of code, integrated CI/CD and GitOps. Automated GitOps workflows replace manual handoffs, accelerating the transition from commit to deploy. At the center, shift-left testing catches defects earlier, speeding time to market. The bottom graph proves the financial outcome. Operational costs remain completely flat, while engineering throughput scales exponentially. This automated layer acts as the financial engine of the enterprise, proving that an organization can drive massive volume without triggering a corresponding linear increase in overhead. The third layer focuses on the software supply chain. Enforcing security policies across hundreds of distributed teams usually grinds development to a halt. These concentric security shields detail a built-in DevSecOps approach with true zero-trust architecture. Integrating code scanning into the pipeline automates policy enforcement, stripping away developer friction. For the CFO, this mitigates financial exposure, avoiding expensive late-stage patches and drastically lowering compliance audit costs. Embedding security protocols directly into the foundational architecture transforms it from a reactive bottleneck into a frictionless business enabler. The fourth layer addresses the human element. Forcing application developers to configure and manage their own infrastructure creates massive cognitive load and slows down output. The solution is an abstraction layer built on developer experience and self-service inner loop tooling. This visual illustrates the golden path. These pre-configured environments ensure absolute local-to-cluster parity, stripping away infrastructure complexity so developers focus purely on logic. Following this path through the outer loop institutionalizes a true platform engineering operating model, completely based on self-service. This drastically reduces onboarding time and ramp-up costs for new engineers. Establishing a golden path maximizes the enterprise's financial ROI on high-cost engineering talent. It allows them to focus solely on writing code, not managing servers. The final architectural layer addresses the risk of vendor lock-in and shifting public cloud markets. This map displays a unified Red Hat control plane spanning across both on-premise infrastructure and multiple public clouds. This setup ensures identical agnostic deployments regardless of the underlying host environment. True portability unlocks dynamic workload placement. Teams can route applications based strictly on real-time cost-to-performance ratios rather than technical constraints. This gives the CFO commercial leverage. Retaining the ability to instantly migrate workloads preserves critical negotiation power against massive cloud providers. Multi-cloud portability functions as a strategic insurance policy, protecting the enterprise from technical disruptions and forced vendor shifts. This full isometric architecture reveals the completed platform. This unified architecture aligns technical execution directly with executive intent. This table maps the 5 capabilities directly to our 3 stakeholder mandates. Development teams gain consistent environments, automated pipelines, and frictionless workflows. Platform engineering secures a scalable foundation, zero-trust architecture, and agnostic future-proofing. Finance locks in lower costs, accelerated revenue, reduced risk, and negotiation leverage. Red Hat OpenShift and the Advanced Developer Suite unite these interests into a single cohesive system. You no longer have to choose between engineering speed, financial control, and security posture. By standardizing the operational foundation, the IDP transforms infrastructure from a rigid cost center into a dynamic strategic lever for the entire executive board.